Number 10. Opabinia, the five-eyed animal that broke the Cambrian Sea. When scientists first reconstructed Opabinia, the room reportedly laughed. Not because the fossil was unimportant, but because the animal looked so impossible that even trained paleontologists struggled to accept it as real. It came from the Burgess Shale, the ancient Canadian fossil bed that preserves some of the strangest life forms from the Cambrian seas more than 500 million years ago. At that time, animal life was exploding into new forms, trying bodies, eyes, limbs, shells, mouths, and survival strategies that had never existed before. But even in that world of experimentation, Opabinia stood apart. It had 5 eyes mounted on top of its head, a soft segmented body, side flaps for swimming, and a long, flexible proboscis extending from its face, ending in a claw-like structure. It did not look like an ancestor of anything familiar. It looked like evolution had briefly forgotten its own rules. The first shock was the eyes. Most animals are already unsettling when their eyes face the wrong direction. But Opabinia had 5 of them arranged like sensors on a living machine. In the dim Cambrian water, those eyes may have helped it scan above and around itself while searching for food or avoiding predators. Then came the proboscis, the feature that made the creature almost absurd. Instead of a normal mouth at the front, Opabinia's feeding claw reached outward like a flexible arm, grabbing small prey or particles and bringing them back toward a mouth underneath the head. It was as if the animal had separated the act of catching food from the act of eating, building a body plan that seems awkward to us only because nothing like it survived. And what makes Opabinia so important is that it exposed how strange the Cambrian really was. For a long time, people imagined early animal life as simple and unfinished, as if the ancient ocean were merely a rough draft of the world we know today. Opabinia shattered that picture. It showed that the early seas were not filled only with obvious ancestors waiting to become modern animals. They were filled with experiments, some successful for a time, some doomed, some so unusual that their place on the tree of life remains difficult to explain. Opabinia was not a failed sketch. It was a living animal adapted to its own world. It swam, fed, avoided danger, reproduced, and survived long enough to leave its shape pressed into stone. The fact that it looks wrong to us says more about what disappeared than about what it was. But this deeper horror is that Opabinia represents a branch of possibility that vanished. Its body plan did not lead clearly to the creatures we see around us now. No modern animal walks, swims, or hunts with 5 eyes and a clawed hose on its face. It belonged to a time when evolution was testing designs that would later be erased by extinction, competition, changing oceans, and the brutal filtering of deep time. If the Burgess Shale had not preserved it in extraordinary detail, Opabinia might be completely unknown, and we would never suspect that such an animal had existed at all. That is what makes it disturbing. It was not legendary, not imagined, not the invention of a myth. It was real, and it lived in an ancient ecosystem that no longer has a living witness. Opabinia also reminds us how fragile scientific certainty can be when the subject is 500 million years old. Paleontologists must reconstruct entire animals from flattened impressions, mineral stains, crushed tissues, and shadows left in rock. A misplaced structure can become a head. A feeding organ can become something else. A strange body can be forced into a familiar category because the human mind wants the past to make sense. But some fossils resist that comfort. Opabinia does not allow the Cambrian to become neat. It stands in the record like a warning that the history of life is not a straight line leading inevitably to us. It is a graveyard of abandoned forms, and sometimes one of those forms is preserved well enough to show us how little we expected. That is why Opabinia belongs among the prehistoric creatures that should not have existed. It was not the largest predator, not the most armored animal, and not the deadliest thing in its sea, as its horror is stranger than size or violence. It is the horror of a body that proves nature once made choices we can barely imagine. 5 eyes watching the Cambrian water, a clawed proboscis reaching through the mud. a soft body swimming through a world before bones, forests, birds, mammals, or humans. Opabinia was not a monster to its own age, it was normal there. And that is the most unsettling thought of all. The prehistoric world was once filled with creatures that would look impossible to us, and most of them disappeared before stone could remember their names. Number 9, Anomalocaris, the first apex predator that looked like a nightmare. Before sharks, before giant marine reptiles, before the first fish became rulers of the sea, there was Anomalocaris. It lived more than 500 million years ago, in the Cambrian oceans, when animal life was still experimenting with eyes, armor, shells, limbs, and fear itself. To the creatures around it, Anomalocaris must have seemed like something the world had not yet learned how to defend against. It was large for its time, built for swimming, with a flattened body, side flaps that moved like fins, huge compound eyes, 2 curved grasping appendages hanging from the front of its head, and a circular mouth made of hard plates. It did not look like a fish. It did not look like a crustacean. It looked like a weapon assembled from parts evolution would later abandon. When its fossils were first discovered, scientists did not even understand they belonged to one animal. The mouth was mistaken for a jellyfish. The grasping limbs were thought to be shrimp-like creatures. Other parts were interpreted separately because the complete body plan seemed too strange to imagine. For years, Anomalocaris existed in science as a collection of mistakes, its anatomy scattered across categories that made sense only because no one had yet seen the nightmare whole. When researchers finally realized the pieces belonged together, the Cambrian seas changed forever. What had once seemed like a world of small, soft, simple animals became a place where predators were already large, fast, visually advanced, and specialized for attack. The most disturbing feature of Anomalocaris was its role in the beginning of predation. Before animals like this, life in the ocean had fewer reasons to grow armor, spines, shells, speed, or defensive behavior. But once a predator could see, chase, grab, and crush, every other creature had to respond. Anomalocaris helped turn the Cambrian into an arms race. Its eyes were among the most advanced of its time, giving it the ability to track movement in the water. Its front appendages could seize prey and pull it toward the mouth. Its swimming flaps allowed it to glide through the sea with a level of control that many animals around it likely could not match. In a world still inventing survival, Anomalocaris was already inventing terror. For decades it was imagined as a hunter capable of cracking trilobites, those armored animals that crawled along the seafloor like living shields. The fossils of damaged trilobites seemed to support the idea of a predator powerful enough to bite through their defenses. Later research complicated that image, suggesting its mouth may not have been strong enough to crush the hardest shells in the way once believed. But that does not make Anomalocaris less frightening. It makes it stranger. Perhaps it targeted softer animals. Perhaps it pinned prey, sucked, tore, or fed in ways we still do not fully understand. The creature refuses to become simple. Every time science tries to turn it into a clean answer, the fossil record leaves another shadow. What makes Anomalocaris feel so wrong is that it appeared so early. It was not the product of hundreds of millions of years of familiar ocean warfare. It emerged near the dawn of complex animal life, already equipped with eyes, mobility, weapons, and a predator's body. Its existence suggests that the Cambrian explosion was not gentle experimentation. It was a violent reorganization of life. Bodies became prey, armor became necessary, movement became survival. The ocean became a place where being seen could mean being caught, and being caught could mean being erased. Anomalocaris did not merely live in that world. It helped create it. And then it vanished. No modern animal carries its full design forward. Its body plan, once so successful that it dominated the Cambrian imagination, disappeared into deep time. The seas moved on, new predators rose, fish evolved jaws, arthropods changed, evolution kept the violence but discarded the shape. That is the most unsettling part. Anomalocaris was not a failure while it lived. It was one of the great predators of its age. Yet the world that made it possible ended so completely that today it looks alien, as if it belongs to a version of Earth that should not have existed. That is why Anomalocaris belongs among the prehistoric creatures that should not have existed. It was not just an ancient animal with a strange body. It was a sign that fear entered the oceans early, wearing a form no living creature fully remembers. Its fossils reveal a time when evolution was still deciding what a predator could be, and one of the first answers was a swimming nightmare with grasping claws and a circular mouth. Long before the age of dinosaurs, long before the first forests, long before humans imagined sea monsters, the Cambrian Ocean had already built one. Number 8. Helicoprion, the shark with a spiral saw in its mouth. For more than a century, Helicoprion existed as one of the strangest puzzles in paleontology. Its fossils were not full skeletons or clean outlines of a body. They were spirals of teeth coiled like a circular saw, with almost nothing around them to explain where they belonged. Researchers knew the structure came from an ancient shark-like predator, but they could not agree where the tooth whorl actually sat. Some placed it on the snout like an external weapon. Others imagined it on the back, the tail, the throat, or hanging from the jaw like a loose blade. The creature became a monster assembled from guesses, all because one fossilized spiral looked too impossible to fit inside a real mouth. The Helicoprion lived roughly 290 million years ago, long before the dinosaurs, in seas filled with fish, cephalopods, early sharks, and creatures from older branches of life. It was not a modern shark, but it belonged to the broader world of cartilaginous fish, animals whose skeletons were made mostly of cartilage instead of bone. That is why the mystery lasted so long. Cartilage usually disappears before it can fossilize, while teeth survive. Scientists were left with the most terrifying part of the animal, and almost none of the body needed to understand it. It was like finding a weapon in the dark, but not the hand that held it. The spiral itself was the horror. New teeth grew at the back of the lower jaw and pushed older teeth forward into the coil, instead of dropping away like the teeth of many modern sharks. But over time, Helicoprion carried a permanent archive of its own feeding machinery, a whirl of past and present teeth locked into one structure. Modern scans finally suggested that the spiral sat inside the lower jaw, not outside the body. When the animal bit, the whirl may have rotated backward, slicing soft prey and pulling it deeper into the mouth. It may have hunted squid-like animals and other soft-bodied creatures, cutting and dragging flesh inward with a blade made from its own teeth. What makes Helicoprion so unsettling is that the design seems absurd until you remember it worked. This was not a failed experiment that vanished immediately. It survived for millions of years. It grew large, hunted successfully, and moved through ancient oceans with a mouth unlike anything alive today. Modern sharks frighten us because their jaws are simple and efficient. The Helicoprion frightens us because its jaw seems engineered from a different imagination. It did not merely replace teeth. It kept them, arranged them, and turned them into a hidden saw. The animal was not carrying decoration. It was carrying a feeding system that looked wrong to us only because evolution later abandoned the idea. The deeper mystery is why that idea disappeared. Evolution kept sharks. It kept cutting jaws, fast marine predators, and replaceable teeth. But it did not keep the spiral saw. No living animal gives us a clean explanation for why this structure once made sense. Helicoprion belongs to a world where the rules of predation were still being tested, where ancient seas allowed strange designs to rise, dominate, and vanish without descendants that could translate them for us. It is not frightening because it was impossible. It is frightening because it was possible once, under conditions that no longer exist, in oceans that built predators from shapes we would never expect. For generations, Helicoprion was drawn incorrectly because the fossil record gave only fragments, and the fragments looked insane. That is the lesson hidden inside its teeth. Deep time does not hand us complete creatures. It gives us broken evidence and asks us to rebuild entire lives from the hardest parts that remain. A single tooth spiral created decades of competing monsters because the real animal had mostly disappeared. But when the whirl was finally placed inside the jaw, the creature became more believable and somehow more disturbing. The saw was not a mistake, it was the mouth. That is why Helicoprion belongs among the prehistoric creatures that should not have existed. It was a shark-like predator with a spiral blade hidden in its jaw, hunting real prey beneath skies no human would ever see. Its body is mostly gone, but the whirl remains, a fossilized question mark made of teeth. It reminds us that evolution does not always choose shapes that look sensible from the present. Sometimes it builds a saw, folds it into a mouth, lets it cut through the sea for millions of years, and then erases the creature so completely that all we inherit is the blade. Number 7. Dunkleosteus, the armored fish that bit like a guillotine. Long before sharks became the symbol of ocean terror, the Devonian seas belonged to armored fish. Among them, Dunkleosteus was one of the most frightening predators the ancient world ever produced. It lived more than 300 to 50 million years ago, in oceans filled with reef systems, early fish, armored creatures, and experiments in vertebrate evolution that looked nothing like the sea life we know today. Its head and chest were covered in thick plates of bone, turning the front of its body into a living fortress. But the real horror was its mouth. Dunkleosteus did not have teeth like a shark or a crocodile. It had sharpened bony plates that closed together like blades, slicing through prey with a force that made it one of the most dangerous animals of its age. But the skull of Dunkleosteus looks less like the head of a fish and more like a weapon designed around a hinge. Its jaws could open with incredible speed, creating suction that helped pull prey inward before the plates snapped shut. Once the mouth closed, the cutting edges would shear through flesh, armor, and bone. In a world where many animals relied on shells, scales, and external protection, Dunkleosteus evolved a bite that turned defense into a temporary problem. It did not need delicate teeth that could break or fall out. Its entire skull had become part of the killing mechanism. The predator carried its weapon in the architecture of its face. What makes Dunkleosteus especially unsettling is how incomplete our picture of it still is. Its armored head fossilized well, but much of the rest of its body was made from cartilage, which rarely preserves. For generations, scientists had to reconstruct the creature from the part most likely to survive, the skull. This means the image we have of Dunkleosteus is dominated by its mouth, its armor, and its killing surface. The body behind that head remains more uncertain, a shadow attached to a guillotine. Even debates about its exact length and shape remind us how much of the animal has been lost. The fossil record kept the weapon and erased much of the creature that carried it. In the Devonian Ocean, Dunkleosteus would have been a ruler of violence. It hunted before marine reptiles, before whales, before the familiar predators of later seas. It belonged to a group called placoderms, armored fish that were once among the most successful vertebrates on Earth. For millions of years, they filled ancient waters with hard faces, heavy plates, and brutal jaws. Then they vanished. To the end, Devonian extinctions erased them so completely that no living placoderm remains to show us exactly how they moved, behaved, or experienced the world. Dunkleosteus was not a primitive failure waiting for better predators to replace it. It was a dominant form of life in its own time, powerful enough to make the ocean organize itself around fear. The most disturbing thing about Dunkleosteus is that it shows how early vertebrate predation became extreme. This was not a gentle stage of evolution where backboned animals were slowly learning to survive. The arms race had already escalated into armor thick enough to protect the head and jaws, strong enough to cut through almost anything they caught. Life did not wait for dinosaurs or mammals to invent terror. It built a bladed skull in the Devonian Sea and let it rule. Every smaller fish that swam near Dunkleosteus entered a world where the difference between life and death could be the sudden opening of a mouth and the collapse of two bony knives. And then, like so many powerful ancient forms, Dunkleosteus disappeared. The oceans changed, extinction struck. The placoderms were removed from the future, and other predators inherited the seas. Sharks continued, bony fish diversified, later ages produced reptiles, whales, and giant hunters of new kinds. But the armored fish with the guillotine mouth did not return. Evolution kept the idea of the predator, but abandoned this version of it, a head like a shield, jaws like shears, and a body we can only partly imagine moving through dark water. That is why Dunkleosteus belongs among the prehistoric creatures that should not have existed. It was not strange because it was weak or badly designed. It was strange because it was too successful in a form that no longer fits the modern world. Its fossil skull feels like the remains of an abandoned weapon, proof that the ancient ocean once built predators from armor and blades instead of teeth and speed. When we look at Dunkleosteus, we are not looking at a monster from fantasy. We are looking at a real animal from a real sea, a time when evolution gave a fish a face like a fortress and a bite like an execution machine. Number 6. Arthropleura, the giant millipede larger than a human, long before insects became small things crushed underfoot. The Carboniferous forests belonged to giants. The air was warmer, wetter, and richer in oxygen than the world we know today, and the land was covered in vast swamp forests filled with towering club mosses, ancient horsetails, ferns, and decaying vegetation. In that green, humid world, arthropods pushed beyond the sizes that seem possible now. Dragonflies grew with wings like birds. Scorpions and spiders became larger and more threatening. But among the strangest of them all was Arthropleura, a millipede-like creature that could grow longer than a human being, crawling through the forest floor like a living armored rope from a world before mammals, birds, flowers, or dinosaurs. The Arthropleura lived more than 300 million years ago, and for a long time its fossils seemed almost impossible to accept. Its body was made of many segments protected by hard plates, wide enough that its trackways looked like something heavy had dragged itself across ancient mud, with rows of legs moving in rhythm. Some individuals may have reached lengths of more than 2 meters, making it one of the largest land arthropods ever known. To imagine it alive is to imagine the ground itself moving, a huge segmented body sliding through wet vegetation, its armor scraping over roots and fallen plant matter, its countless legs carrying it through forests where the rules of size were different. What makes Arthropleura unsettling is that it was probably not a monster in the way people expect. It may not have been a predator tearing animals apart. Many researchers believe it fed mostly on plant material, decaying vegetation or softer organic matter from the forest floor. But that almost makes it stranger. A creature does not need to hunt to be horrifying. Sometimes size alone is enough. A millipede-like animal longer than a person, moving through a swamp forest in silence, does not need venom, claws, or teeth to feel wrong. It represents a version of Earth where even the harmless things were enormous, where the background life of the forest could become larger than the humans who would not evolve for hundreds of millions of years. Its size was made possible by a world that no longer exists. The Carboniferous atmosphere held far more oxygen than today, allowing arthropods that breathe through body openings and internal air tubes to grow much larger than their modern relatives. And the climate, the swamps, and the abundance of plant material created a temporary window in which creatures like Arthropleura could thrive. But that window eventually closed. Oxygen levels changed, forest ecosystems shifted, the humid coal swamps fragmented. The conditions that allowed land arthropods to become giants disappeared, and with them vanished the possibility of Arthropleura itself. Evolution did not simply choose smaller descendants. The planet withdrew the permission that had allowed such a body to exist. The fossil record of Arthropleura is also frustratingly incomplete. For years, scientists had only fragments, body plates, trackways, partial remains, and scattered pieces that hinted at the animal's full scale without always revealing its full anatomy. But the creature was reconstructed from evidence left in stone, but Like so many prehistoric giants, it exists partly as certainty and partly as shadow. We know it was real, we know it was huge, we know it crawled across ancient land. But the details of how it lived, how it sensed the world, how it reproduced, how it behaved when threatened, and how common it truly was remain locked inside a forest that turned to coal before the first dinosaur ever walked. That is why Arthropleura belongs among the prehistoric creatures that should not have existed. It was not a dragon, not a sea monster, not a predator with a mouthful of blades. It was something more quietly disturbing, proof that the ordinary categories of modern life are not permanent. Today, millipedes hide under leaves and stones. In the Carboniferous, something like them could become a giant of the forest floor. The creature reminds us that nature does not have fixed limits. Change the air, change the climate, change the plants, and the small things can become enormous. Arthropleura was not an exception to Earth's rules. It was what happened when the rules were different. And somewhere in the coal-black memory of ancient swamps, the ground still remembers the age when a millipede could be larger than a man. Number 5, Meganeura, the dragonfly with wings like a hawk. Before birds filled the sky, before bats hunted in darkness, before pterosaurs stretched leather wings over prehistoric oceans and forests, the air belonged to insects. In the Carboniferous world, more than 300 million years ago, the atmosphere itself was different. Oxygen levels were higher, swamp forests spread across the continents, and the sky above those humid green landscapes carried creatures that would look impossible beside their modern descendants. Among them was Meganeura, a dragonfly-like predator with a wingspan that could reach the size of a hawk. It was not a delicate insect hovering over a pond. It was a flying hunter from an age when the small things of today had not yet been forced to remain small. Meganeura lived in forests filled with giant club mosses, ancient ferns, wet ground, and endless decay. The world beneath it crawled with early amphibians, huge arthropods, and insects that had not yet faced the aerial competition of birds. In that open sky, Meganeura became one of the first great predators of the air. Its large compound eyes would have helped it detect movement with terrifying precision. Its long body and powerful wings allowed it to patrol above water, vegetation, and swamp clearings. Its prey may have included smaller insects and possibly other airborne creatures that had no experience with a hunter of that scale. To them, Meganeura was not just a dragonfly. It was the shadow overhead. What makes Meganeura so unsettling is that it takes something familiar and enlarges it until the familiar becomes wrong. Modern dragonflies are already efficient predators, capable of sudden acceleration, precise turns, and deadly attacks on other insects. Now imagine that same basic form expanded to a wingspan wider than many birds, moving through thick, prehistoric air above forests with no songbirds, no bats, and no human eyes to witness it. It did not need claws like a dinosaur or teeth like a reptile. Its horror was in the idea that an insect could become a ruler of the sky. The body plan that now seems fragile once became powerful enough to dominate an entire aerial world. Its size was possible because the planet briefly allowed it. Insects breathe through tiny openings and internal tubes rather than lungs like ours, and that system limits how large many modern insects can become. But during the Carboniferous, the richer oxygen atmosphere may have helped insects grow far beyond their modern limits. The environment became a temporary laboratory of giants. Arthropods stretched across the forest floor and insects expanded into the air. Meganeura was not an accident. It was the result of a world where oxygen, climate, and ecology opened a door that later closed. When atmospheric conditions changed and new flying vertebrates eventually evolved, the age of giant insects could not last. The fossil record turns Meganeura into something almost ghost-like. Its delicate body should not have survived at all, yet impressions of wings and fragments preserved enough detail to reveal how large it had been. The wings still carry the structure of flight, thin and veined, pressed into stone like the memory of something that once moved too quickly to be caught. We do not have its full life, its colours, its behaviour, its exact hunting patterns, or the sound its wings made over the Carboniferous swamps. Whomps. We have only enough to know that the sky once held insects on a scale that would make the modern world feel unsafe. That is why Meganeura belongs among the prehistoric creatures that should not have existed. It was not strange because evolution failed. It was strange because evolution succeeded under rules that no longer apply. Today, dragonflies flash above ponds like small living jewels. In the Carboniferous, their ancient relatives could become airborne predators large enough to cast a shadow. Meganeura reminds us that the present is not the standard by which nature must be judged. Change the air, change the competitors, change the world, and the sky can fill with giants. Long before feathers, long before wings of bone and skin, long before humans looked upward and imagined monsters, an insect already ruled the air. Number 4, Jaekelopterus, the sea scorpion. Bigger than a man, long before the oceans belonged to sharks, reptiles, or whales, they belonged to stranger things. In the Silurian and Devonian worlds, ancient waters were filled with armored fish, jawless creatures, early predators, and arthropods that had not yet accepted the small sizes we associate with them today. Among the most terrifying was Jaekelopterus, a giant sea scorpion whose fossil claw suggests an animal larger than a human being. It was not a true scorpion in the modern desert sense, but a eurypterid, part of a vanished group of aquatic arthropods that once ruled rivers, lagoons, and shallow seas. To imagine it alive is to imagine something like a nightmare lobster, scorpion, and armored predator combined, moving through ancient water with grasping claws large enough to make a human hand seem fragile. The fossil that made Jaekelopterus famous was a claw fragment, but that fragment was enormous. From it, scientists estimated that the complete animal could have reached more than 2 meters in length, making it one of the largest arthropods ever known. Its body would have been segmented and armored, with limbs adapted for movement and powerful pincers at the front for seizing prey. In its world, fish were evolving jaws, predators were becoming faster, and the arms race of aquatic life was becoming more brutal. Jaekelopterus was part of that escalation. It did not need teeth like a shark or a skeleton like a reptile. It had armor, limbs, and claws built for control. Once something was caught, escape would have been almost impossible. What makes Jaekelopterus unsettling is that it turns the familiar idea of arthropods into something too large for comfort. Today, crabs, scorpions, spiders, and insects are usually terrifying because they are alien in shape but limited in size. We can step away from them, trap them, crush them, or remind ourselves that they are smaller than we are. Jaekelopterus removes that comfort. It belonged to an age when arthropods could compete at the scale of vertebrate predators, when the jointed bodies we now associate with small creatures could become dominant hunters. The ancient water did not care about the boundaries that make the modern world feel normal. It allowed a sea scorpion to become a giant. Its existence also reveals a lost chapter in the battle between arthropods and vertebrates. Eurypterids were once among the great predators of aquatic ecosystems, but their world changed as jawed fish became stronger, faster, and more diverse. Over time, the balance shifted. Fish rose. Eurypterids declined. To the bed, the giant sea scorpions vanished, leaving behind only fossils to show that arthropods once challenged early vertebrates for control of the water. Jaekelopterus stands at the edge of that lost war, a reminder that the future of life was not always destined to belong to backboned animals. There was a time when the rulers of the water had external armor, segmented bodies, and claws. The fossil record gives us only fragments, and that makes the creature more disturbing rather than less. We do not have a perfect moving image of Jaekelopterus. We have pieces, measurements, comparisons, and reconstructions built from relatives that are also long extinct. But the claw is enough. It tells us that something huge once reached through ancient water and closed around prey with a grip no modern animal can fully translate. The rest of the body has to be rebuilt from stone and inference, but the message of the fossil is clear. This was not a harmless curiosity. This was a predator from a world where the line between sea monster and arthropod had not yet been drawn. That is why Jaekelopterus belongs among the prehistoric creatures that should not have existed. It was not a myth invented by sailors or a monster exaggerated by fear. It was real, and it lived before the familiar ocean took shape. Its horror comes from scale, from the idea that a body plan now associated with scorpions and crabs once produced animals large enough to dominate waterways. Evolution later abandoned that path, and the age of giant sea scorpions ended. But for a time, in ancient rivers and shallow seas, the water held creatures with armored backs, jointed limbs, and claws bigger than anything a modern mind wants to imagine. The Jaekelopterus was not a monster because it broke nature's rules. It was a monster because nature's rules were different then. Number 3. Therizinosaurus, the dinosaur, with claws too large to explain. For decades, Therizinosaurus was known less as an animal than as a set of impossible claws. When its first fossils were found in Mongolia, scientists did not have a complete skeleton, a clear body shape, or an easy place to put it on the dinosaur family tree. They had enormous curved bones that looked like weapons from something terrifying. The claws were so long that early researchers thought they might belong to a giant turtle-like reptile, perhaps used for pulling seaweed or moving through water. The idea sounds strange now, but the fossils gave so little context that almost anything seemed possible. Therizinosaurus entered science as a mystery made of blades. Later discoveries revealed that the truth was even stranger. Therizinosaurus was not a turtle-like reptile. It was a theropod dinosaur, part of the same broad group that included famous predators and eventually birds. But instead of becoming a sleek hunter, it developed into something almost absurd, a huge-bodied, long-necked, pot-bellied dinosaur with powerful arms and claws of astonishing length. It walked on 2 legs, carried a small head compared with its body, and may have been covered in primitive feathers. Everything about it seemed to contradict the normal image of the theropod predator. It had the ancestry of a meat-eater, but the body of something else entirely. The claws remain the center of the horror. They were not small cutting tools or simple grasping fingers. They were enormous scythe-like extensions, among the longest claws known from any animal. Mal, a creature standing beside Therizinosaurus, would have seen arms ending in curved blades long enough to make the dinosaur look like a walking nightmare. Yet the purpose of those claws remains debated. They may have been used for pulling branches toward the mouth, stripping vegetation, defending against predators, display, competition, or some combination of all these things. That uncertainty makes them more unsettling. Nature built one of the most frightening hand weapons in dinosaur history, and the animal that carried them may have used them mainly to eat plants. That contradiction is what makes Therizinosaurus feel like it should not have existed. It looks like a monster designed for slaughter, but much of the evidence suggests it belonged to a strange branch of herbivorous or omnivorous theropods. Its large belly may have processed vegetation, as its long neck could help it reach leaves. Its beak-like mouth and small head do not fit the image of a predator tearing flesh. But the arms tell another story. Even if they were not used for hunting, those claws would have made the animal dangerous. A predator approaching too close could have faced a sweep of bone blades from a creature far larger than a human. Therizinosaurus was not built like a normal plant-eater. It was a herbivore carrying the silhouette of a horror film. The world it lived in made that body more believable. Late Cretaceous Mongolia held deserts, floodplains, armored dinosaurs, horned dinosaurs, raptors, tyrannosaur relatives, and countless animals competing for food and survival. In such a place, being strange could be an advantage. A large body discouraged attack, a long neck reached food, a deep gut processed plants. The feathers may have helped with display or temperature, and the claws, whatever their exact purpose, gave the animal presence. Therizinosaurus did not need to fit the categories humans prefer. It only needed to survive in its own ecosystem, and for a time that impossible design worked. What makes its fossil story haunting is how slowly the real animal emerged from fragments. For years, the claws stood almost alone, inviting wrong interpretations because the rest of the creature was missing. Only later did related dinosaurs and additional remains reveal the bizarre family it belonged to. This is the problem with deep time. A single bone can mislead an entire generation. A hand without a body can become a sea reptile, a monster, a predator, or a mistake, until more of the dead world surfaces and forces the picture to change. That is why Therizinosaurus belongs among the prehistoric creatures that should not have existed. It combined features that seem almost incompatible: theropod ancestry, possible feathers, a heavy plant-eating body, a small head, and claws so enormous they still dominate every reconstruction of the animal. It was proof that evolution can take a familiar branch and send it down a path that looks wrong from every modern angle. The dinosaur with the giant claws may not have been the killer those claws suggest, and that is what makes it more disturbing. The prehistoric world did not only build monsters that hunted, sometimes it built peaceful giants armed like an apocalypse. Number 2. Spinosaurus, the river monster that rewrote dinosaur rules. For most of the 20th century, Spinosaurus was imagined as another giant predator walking through the dinosaur age, a strange-backed rival to Tyrannosaurus with a long skull and a sail rising from its spine. But the deeper scientists looked, the less it behaved like the dinosaur they expected. Its fossils told a story that refused to stay on land. The skull was long and narrow like a crocodile's, built for seizing slippery prey rather than crushing bone in the usual theropod way. Its teeth were conical, not blade-like, better for gripping fish than slicing flesh. Its nostrils sat farther back on the skull, and its bones showed unusual density, a trait useful for animals that spend time in water. But piece by piece, Spinosaurus stopped looking like a normal land predator and began to look like something far more unsettling: a dinosaur that had moved into the rivers. That idea disturbed paleontology because dinosaurs were not supposed to do this, at least not at this scale. Giant theropods were meant to dominate land, stalking floodplains, forests, and open habitats on powerful legs. Spinosaurus seemed to challenge that rule. It lived in North Africa during the Cretaceous in a world of enormous river systems, crocodile-like reptiles, giant fish, turtles, pterosaurs, and other predators competing along waterways that may have been as dangerous as any ocean. This was not a peaceful swamp. It was a predator-filled wetland where the line between land and water became blurred. But in that world, Spinosaurus may have hunted from riverbanks, waded through shallows, or even swum after prey, using its long jaws to snap through water like a crocodilian monster wearing the body of a dinosaur. The most controversial part is how aquatic it really was. Some researchers have argued that Spinosaurus was a specialized swimmer with a paddle-like tail, dense bones, and a body adapted for moving through water. Others have pushed back, suggesting it may have been more like a heron or crocodile-like shoreline hunter, spending time near water without being a true underwater pursuit predator. Every new fossil seems to reopen the debate. The tail changes the picture, the legs change the picture, the center of mass, the bone density, the sail and the skull all become evidence in a scientific argument that refuses to settle. So Spinosaurus does not just ask what kind of dinosaur it was, it asks how far a dinosaur could go before it stopped fitting the rules we built around dinosaurs. The sail makes the animal even stranger. Rising from its back in long neural spines, it may have been used for display, species recognition, temperature regulation, fat storage, or some combination we cannot fully prove. On land, it would have made the creature look enormous, a silhouette unlike any other predator. Near water, the sail becomes even more haunting, a dark ridge moving above reeds or breaking the surface of a river, the sign of something huge passing where no giant theropod should be. Whether it was a signal, a weapon of intimidation, or a structure with a lost biological purpose, it turned Spinosaurus into one of the most recognizable and least easily explained dinosaurs ever found. The fossil history of Spinosaurus makes the mystery worse. Some of the earliest and most important remains were destroyed during World War II, leaving later scientists to rebuild the animal from drawings, notes, scattered bones, and new discoveries that did not always agree with each other. Few famous dinosaurs have been reconstructed, destroyed, reimagined, and debated so many times. The animal keeps changing because the evidence keeps arriving in fragments. One generation sees a sail-backed land predator, another sees a river hunter, another sees a possible swimmer. Spinosaurus has become less like a finished animal and more like an argument preserved in bone. That is why Spinosaurus belongs among the prehistoric creatures that should not have existed. It was not just big, it was a giant predator that broke the boundary between dinosaur and river monster, between land hunter and water stalker, between the familiar theropod body and something almost crocodilian in its habits. It reminds us that even the most famous prehistoric animals can still be unstable in our understanding. The past is not fixed just because it is old. Sometimes a fossil rises from the desert and forces an entire category to shift. Spinosaurus was a dinosaur, but it may have lived in a way no other giant predator truly matched. And somewhere in the lost rivers of Cretaceous Africa, the sail-backed monster moved through water, proving that even dinosaurs had shadows we are only beginning to see. Number 1. Tully Monster, the fossil that still refuses classification. In 1958, an amateur fossil hunter named Francis Tully split open a stone concretion from the Mason Creek fossil beds of Illinois and found something that did not seem to belong to any world science understood. The animal inside was small, only about the length of a human forearm, but its body looked like a mistake preserved in stone. It had a soft torpedo-shaped body, a pair of eyes stretched outward on a rigid bar, and a long flexible proboscis ending in a claw-like mouth lined with tiny teeth. It looked part worm, part fish, part nightmare tool, and part creature from a branch of life that had been cut away before anything familiar could descend from it. Tully brought the fossil to experts expecting an answer. Instead, he handed them a problem that has lasted for more than 60 years. But the creature became known as the Tully Monster, and the name almost sounds too dramatic until you see it. It lived around 300 million years ago, when the region that is now Illinois was a warm coastal environment filled with strange marine life. Thousands of specimens have been found, which should have made the mystery easier. Usually, paleontologists struggle because they have too little evidence. With the Tully Monster, the problem is almost worse. There are many fossils, and they still do not agree with any clear category. It has been compared to worms, mollusks, arthropods, conodonts, fish, and lamprey-like vertebrates, yet every classification seems to solve one problem only by creating another. The strangest thing about the Tully Monster is how it refuses to stay placed on the tree of life. At different times, researchers have argued that it was a vertebrate, pointing to structures that might resemble a notochord or internal support. Others have rejected that interpretation, saying the same structures may be gut traces or preservational artifacts. Some studies have focused on the eyes, others on the teeth, body shape, chemistry, or possible internal anatomy. Each new method seems to promise a final answer, and each answer seems to reopen the wound. The creature does not merely look strange, it behaves like a fossil designed to expose the limits of classification. If it was a vertebrate, then it was one of the strangest backboned animals ever found, with a face and feeding system unlike almost anything else in that lineage. If it was not a vertebrate, then the mystery becomes even deeper, because it means a completely different animal group evolved features that can imitate vertebrate anatomy closely enough to confuse modern science. Either possibility is disturbing. One places the Tully Monster inside a familiar branch as an extreme outlier. The other leaves it closer to the edge of the map, a soft-bodied animal from a lost experiment in evolution whose closest relatives may no longer exist in any recognizable form. What makes the Tully Monster so haunting is that it was not rare in its own environment. This was not a single deformed animal or an isolated fossil anomaly. It appears in large numbers, meaning it was successful, common, and adapted to its world. It swam, fed, reproduced, and occupied a place in the ecosystem for long enough to leave behind a record. Yet after that world vanished, its lineage seems to vanish with it. No living animal clearly carries its design forward. No modern creature looks back at us with the same stalked eyes, the same strange body, and the same clawed proboscis. The Tully Monster was ordinary once, and that is the most unsettling part. A creature that seems impossible to us may have been just another animal moving through ancient water. The fossil record often gives comfort by letting us draw lines from past to present. We like ancestors, descendants, branches, and categories. We like the idea that every fossil can eventually be placed into a family, and every mystery can be solved with enough technology. The Tully Monster resists that comfort. It reminds us that deep time is not a clean archive. It is damaged, selective, and full of forms that may have left no descendants to help us understand them. We are trying to classify a lost world using the survivors of a different one. That is why the Tully Monster belongs at number 1. It is not the largest creature on this list, not the most violent, and not the most visually overwhelming. Its horror is quieter. It is the horror of an animal that should be easy to explain because we have so many examples, and yet remains unresolved after decades of study. It proves that the tree of life has broken branches, missing kingdoms, and dead ends that do not point neatly toward the present. Somewhere in the Carboniferous Sea, this creature was real. It moved through the water with its eyes on a bar and its clawed proboscis reaching ahead. Then it vanished so completely that millions of years later, science can still hold it in its hands and not know what it is.